Hello, Internet world. So, of course. Oh, why did that do that? Of course it did. I had it set up perfectly, then I closed something on accident. There we go. All right. So, hello, Internet world. I'm going to start going over some geometry questions first and foremost, because that's what my kids are struggling the most with. But if you have a question, you can just send me a message on Remind, and I will be more than happy to help you out with it. Hold on for a second. Let me clear part of my screen. There we go. Now, as you can see on the left-hand side of the screen, I have my geometry problem. And on the right-hand side is where I'm going to be writing down my work. So the first thing that I'm always going to do for myself on any of these geometric proofs is I am going to first draw the shape. Drawing is very important in geometry. So you have to be able to do this. A, B, C, D. And then I'm going to actually take a look. So what we want to do on the bottom is, you can see it's a flow chart. The thing that we really care about is proving triangle ABD is congruent to triangle CBD by side angle side. So that tells me I'm going to need to find one side that they have that's the same, and then actually no, sorry, two sides, because it's side angle side. I know one side is going to be DB. That's an easy one. Right here, DB is equal to itself. I'm going to set that to be my very last reason. Let's see here. We're going to have DB is congruent to DB, and that's called the reflexive property. So when something is equal to itself because it is itself, that's just reflexive. Now, on the other left-hand side, the very first one is usually going to be some type of written statement. So it says, given BD bisects AC and AC is perpendicular to BD. So my first thinking is going to be, since BD is bisecting CA, that means this and this are congruent. So I'm going to say CD is congruent to AD. Oh, no, I can't say that yet. That's going to be the second one. My bad. CD and AD, that's the second one, because that's the definition of bisect. And the other top one should be my written statement, which I did not write down, was given BD bisects. Where is it? BD bisects, yep. So BD bisects AC. That's going to be our given. Okay. So now we have that going on. Over here, we can sit here and... Oh, actually, no. I messed up already again. Both these need to get scooted over one. Darn it. Good thing I keep reading and reading and reading. All right, so let's try this again. This is bisecting BD and AC. That's our given. So that one's gone now. And now on this one, we can say CD is congruent to AD because bisector. This is what the definition is. That's gone. This one is going to be the longer one. We want perpendicular. We want to say AC is perpendicular to BD. That's our given. Now, we can now say that they're both right angles. Because if something is perpendicular, it means that it's going to be 90 degrees. So our two angles that we're going to use is CAD, and the other one, ADB, are right angles. And then we're going to say perpendicular lines from right angles. Then after that, we're going to sit here and say that those two angles are equal to each other now. So CAD is congruent to ADB. And the reason for that is going to be all right angles are congruent. So I'm going to hit submit answer. And hopefully I am right after all that. Nope, I messed up. Let's see here. I had the reflective property down. BD bisect AC given. CD and AD congruent. Segment bisected divides into two segments. That's correct. It's just the letters are in a different spot. And then perpendicular lines, and CAD. Did I label my picture wrong? AC and BD. No, CDB. CDB. Oh, I typed in letters wrong. Yep, that happens. So, always triple check your letters. So let's try one more of these before I move on. All right. So number 2. Hopefully I write all my letters correctly this time, because it happens. All right, so I'm going to draw my 2 pictures. Let's see here. A, B, C, D. A, B, C, D, E. We are given that this and this are the same. Now, what we are going to do is our first one is going to be our given statement. E is a midpoint. So where is it? Boom. Letter E is a midpoint of AC. That's a given. Huh. Okay. That's what's going to happen there. So, from there, we now can say E is a midpoint of AC. That means we can state that CE and AE are congruent because of the definition of midpoint. So I'm going to type in midpoint, and there's our only option. A midpoint divides a segment into 2 congruent segments. Now, that's our side. We need our angle. And if I'm looking at this, yep, this is 10th grade math. This is going to be our angles that we need. You know what? I'm going to write it down before I completely mess up. And we said these two. So for my blue angle, I'm going to start with the letter D, E, C, D, E, C. And then D should match up with B, E, A. All right, let's see if I can make sure I type everything in correctly this time. So D, E, C and B, E, A. And that reasoning is going to be called vertical angles. So when an angle is across from another angle, like the 2 blue ones are, that is called vertical angles. And finally, the last one is going to be what's given to us, which is a congruent statement of 2 lines. DE is congruent to BE, and that's going to be given because it's already in the picture. So let's hit submit. Did I get this one right? Yes, I got that one right. Woo! So even though I messed up all my letters, I don't give up and I keep trying. All right. So next I'm going to go back and I'm going to work on the larger proofs. So here we have a more traditional proof. And instead of writing down the entire proof to the side, I'm just going to draw my pictures because drawing pictures really helps me out. So first, we have 2 triangles, like so. There's no B. Wow. Okay, so this is A, this is C. We have the letter D here. We have an E and an F. In our given, we are given that DE and DF are the same. And we are also given that angle A and angle C are the same. Now, if you recall, we were talking earlier today about the 5 different options: side, 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 angle, side, angle, side, angle, 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 side, and HL. And once again, HL is only used. Oh, you can't see that over there. There we go. HL is only used when we have a right triangle. Nowhere in here does it say anything about perpendicular lines or right angles. So I'm going to automatically just cross out HL. That's not going to work. I'm also going to cross out side, side, side because we have an angle. So now we need to find either another side or another angle. Well, I'm going to look at these 2 blue angles. They're vertical angles. They are directly across from each other. So that would be angle E to D to A is congruent to angle E matches up with F, DC. They are vertical angles. So my statement, I'm going to say 2 angles, EDA and angle FDC. And I'm going to say vertical. Angles are congruent. I'm going to hit the try button and voila, they work. So now, I now have enough to prove either angle, angle, side or angle, side, angle. Well, if I look at this, we have an angle to another angle to a side. So that's going to be angle, angle, side. I look where the proof is up here on the computer. Oh, my iPad disappeared. That's weird. Hold on, let's see if I can get that back. It says it's connected, and there we go. All right, so as you can see, on the left-hand side, I highlighted the triangles that are congruent. So I'm just going to go and click the 2 triangles congruent. A, D, E, and C, D, F. And we said angle, angle, side. Angle, angle, side. Hit try. Submit answer. And we're done. That's it. Let's do another one like this. Because that's all this is just practice back and forth, back and forth. So we have 3 statements of given, and we need to prove that 2 triangles are congruent. So I'm going to draw my picture again. And I have a cross. We have A, B, C, D. A to B to C to D. And this guy and this guy are parallel. That's what those 2 red lines make. So now we got to find how ABC is congruent with CDA. So something that I'm going to do is I'm going to separate this into the 2 different pictures. And you will notice that both pictures share AC in common. So we can sit here and say AC is congruent to AC. AC congruent to AC because that's reflexive. That's the reflexive property. That'll give us a side, which is nice. So AC and AC and reflexive, try, bingo. So then we can stop and think again. Side, 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 angle, side, angle, side, angle, 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 side, and HL. Well, we have a side, so that's good. That's something to go with. Now we got to figure out something else. Well, we can now say that AB is perpendicular to BC, which that makes that a 90-degree angle. So we can say angle ABC is 90 degrees because it's a definition of perpendicular line. And boom, we now have that down. We can also say, since AD and CD are perpendicular, we can also say that's another 90-degree angle. So we can say another right angle. ADC is also a right angle, which means we can now state that both those, oopsie, not line segment, both the angles are identical. Now, here's the problem. ABC matches CDA. It's backwards. Because all right angles are congruent. Try, boom, there we go. All right, so now we have a side and we have an angle. In order to prove HL, hypotenuse leg, we would need one of the sides of that rectangle to be the same, which we can't do that right now. However, we have not touched the idea of parallel lines. Well, parallel lines means that this angle in pink and this angle in pink or purple are congruent. So I can sit here and say angle BCA is congruent, BCA, to angle DAC by alternate interior angles. So, click on the angles again, BCA, and DAC by, oh, that's a lot, I can't see it, so I'm going to type in interior, there it is. Parallel lines cut by transversal form congruent alternate interior angles. Done. There we go. So now we know that this angle and this angle are the same. Well, we now have enough information to say that these two triangles are congruent. We are going to be using angle, side. So two triangles, I'm going to automatically click angle, side, and I'm going to type in my triangle ABC and CDA. Try. Bingo. Submit. All done. There we go. Another problem is done. So that's all I have planned for right now. If you have any questions though, feel free to send me a remind message. If not, you can always tune back into this video. This is our 10th grade geometry. If you have an algebra question or a regular math 3 question on functions, because that was the homework in the classwork, feel free to send me a message. I am going to wait a couple minutes, and if I do not get anybody asking questions by 7:25 about math, I'm going to head off, and I hope this was helpful to anybody. All right. And so I'm going to call it for today. Thank you for tuning in and watching. Hope this helped.